Okay, solve the equation. 7 equals a minus 3 and 2/7. You see, we want to get the variable by itself, a, and so we have to get rid of this thing then. So I'm going to do that by doing the opposite, which if it's subtracting like it is here, that's addition. And then you always do it to the other side of the equation. So both sides needs to have the same thing written there. Now we have a equals 7 plus 3 and 2/7. Okay, now when you're adding mixed numbers, it's quite simple to do. Really, what this is the same thing as saying 7 plus 3 plus 2/7 equals a, and then you can see, well, 7 plus 3 is just 10, and then it's 10 and 2/7 equals a. So adding mixed numbers, it tends to be easier. When you subtract mixed numbers, that's when it becomes a little bit more confusing, and that's when I recommend changing to an improper fraction and then solving. So I'll just do it that way here, even though you don't necessarily need to do it this way, but I'll just show you the process. 7 times 3 is 21. 21 plus 2 is 23 over 7 equals 9. Now I need to get this 7 to be over 7 as well, to have common denominators. I'm going to multiply by 7 on top and bottom. And that gives me 49 over 7 plus 23 over 7. And 49 plus 23 is going to be, see, 49 plus 3 is 52, plus 20 is 72 over 7. And now we ask the question, how many times can 7 go into 72? It can go in there 10 times. 7 times 10 is 70. And there's 2 left over, right? There's 2 left over. You always keep the same denominator, which is 2/7. That's what we found before. So I've just shown you that they're the same way. This first method is a lot simpler, but it works best when you have addition of mixed numbers. When you have subtraction, in my mind, it's easier to do the improper fraction. But this thing, if you're going to do it this way, you always need to make sure that you simplify the fraction. So first off, if I had something like 1 and 2/3 plus 3 and 3/4, you need to make sure you have common denominators. So that would be 12. 1 and 8/12 plus 3 and 9/12. And now adding up is quite simple. 1 plus 3 is 4. 8 plus 9 is 17 over 12. So this is the same thing as 4 and 17/12. However, the numerator here is larger than the denominator. That's an improper fraction, and so we can simplify that. 12 can go into 17 once, and there's 5 left over. And now we have 5 and 5/12. So this is your final answer. So 1 and 2/3, just clean this up a little bit. 1 and 2/3 plus 3 and 3/4 is 5 and 5/12. You always have to adjust the fractions and then always make sure you change them to mixed numbers if they're improper. That's kind of where this thing can be confusing, especially for subtraction, because it's more likely that you're going to have to readjust the fractional part. If you go the improper route, I should say not improper route, but improper fraction route, you don't have to worry about any of that until the very end. But when you do the other way, you have to do it mid process. If it makes sense to you, then go for it. But if not, I recommend you use the thing here. I recommend doing the improper fraction. 10 and 2/7. That's correct. Okay, solve this equation. Hopefully you see what we need to do here. We need to only divide out a -10. That's how we get y by itself. Negative divided by negative is positive. 85/10. It says simplify your answer, type an integer, so a number without a decimal, or a decimal. This is definitely a decimal. You can type it in your calculator, but this one's actually quite easy. We're divided by 10, so we count 1 0 over, 1 0 over, and we get 8.5. You can also just use a calculator for that, but 8.5 is what you're going to get. The frequency, f, in waves per second, and the wavelength, w, in meters, of a sound traveling in air are related by the equation frequency times wavelength equals 343, where 343 meters per second is the sound of speed in air. We're going to calculate the wavelength of a musical note with a frequency. Frequency, they actually use this like fancy f, is 280. It says waves per second. It's not technically waves per second. It's actually 1 per second. It's called a hertz, but we'll just have it in waves per second to keep the idea. I understand why they said that. So we also have the formula frequency times the wavelength equals 343. Yeah. Frequency is 280, so we have 280 times W. And now all we have to do is solve for W, because that's what we're trying to do, is calculate the wavelength. So divide by 280. Divide by 280, and that gives us W equals, it says round, type an integer or a decimal rounded to three decimal places. Wow. 343 over 280 gives us 1.225, and it wants 3, so that's all we need to do. The actual formula for this, in general, is frequency times wavelength equals the speed of light, and it's very important for a lot of physics calculations.